Hi students, in this lecture I will explain how to draw the tree diagram for a given convolutional encoder, and also we will find output of the given convolutional encoder for the input bit stream 11101. Here the question below figure depicts rate of constraint length 1 convolutional encoder. Sketch the tree diagram. Also find encoder output for the given input data. In the given convolutional encoder, the first flip-flap is MSG and the next is for M1. So here MSB is used to hold current message bit and M1 represent state of the encoder. Only one bit is result for the state of the encoder, because the constraint length of the given encoder is 1. L is equal to 1. As one bit is result for the state, only 2 to the power of n 2 to the power of 1 is equal to 2 states are possible, state 0 and the state 1. If 2 bits are used for state representation, we can have 4 possible states. If 3 bits are used or constraint length is 3, we can have 8 possible states. If 4 bits are used, then we can have 16 possible states.
Let us understand how to prepare a state table for a given convolutional encoder. Initially, the given the encoder is at all 0 state, 0 state. Initially, it will be in 0 state. So state of the encoder is represented as M1, and initial state. Initially, it is in all 0 state. And see, the state of the encoder depends on the incoming message bit. Whether the incoming bit is 0 or whether the incoming bit is 1. So the change of state depends on the incoming message bit. So see here, for initial state 0, let us assume 0 state. If the incoming bit is 0, it is in the 0 state. If the incoming bit is 1, 0 state, initial state. Because 0 and 1, because it is a binary convolutional encoder, we have only 2 possibilities. The incoming bit may be 0 or may be 1. Again, initial state, we assume 1 1 for incoming bit to 0 and 1. So state 0 is represented with letter A. Let us represent bit 1 represent state B. State 1 is represented with letter B. So initial state may be AA, BB, something like this. If 2 bits are used for the state representation, in the case of constraint length 2, we can have 4 states, and we assume 0 represent A, 1 represent B, 10 represent C, and 11 represent D. But in our example, only 2 states are available, either state A or state B. First, we try to find encoded output of the encoded output of the convolutional encoder, given convolutional encoder. From this diagram, we can say x1 is equal to MSG. This is MSG, and this is M1, and x2 second output MSG, exclusive OR of MSG plus M1. So this is the output to 2 and output to 1. So here, we can find directly x1 x2. The output, final output will be, we represent with x1 x2 x1 x2 x1 x2 like that. So if you find, suppose if MSG is 0, we get x1 is equal to 0, x1 is equal to 0 we get. This is x1 x2. If x2 will be, m1 is 0 and MSG is 0, we will get 0 plus 0. This will be 0 0. So the output of the encoder will be 0 0. Similarly, we can find output of the encoder using these equations. Here this symbol represents XOR logic or modulo 2 addition. Let us calculate the next states of a given convolutional encoder. The state of the encoder changes only after applying the clock pulse. If you apply clock pulse, then only the state of the encoder or shift register will get changed. Suppose the encoder may be at 0 state or 1 state, depending on the initially at 0 state or 1 state, depending on the incoming message bit. In step 1, suppose let us assume it is at 0, the state of the shift register or the state of the encoder is 0, and if this red bit, the bit color in red represents incoming bit. If the incoming bit is 0 and the state of the shift register is initially at 0, after applying the clock pulse, this 0 goes out. It will be discarded. This 0 comes to, sorry, this, okay, after right shift by 1 bit, this 0 will be discarded and this will come to M1. MSG will come to M1 after applying 1 clock pulse, right shift by 1 bit. So the state of the encoder changes from 0 to 0. So that is why 0 represents A. The state changes from current state, present state A to next state A. And in the second step, we assume initial state is 0 and we assume the incoming bit is 1. The incoming bit is 1. So these are the contents of the shift register. Then the state will change after applying the clock. So this 0 will be discarded and this 1 will come to M1 place. So M1 represents state of the encoder. So state of this one represents state B. So it changes from initial state 0 to state to B. State to B. If the incoming bit is 1 and initial state is 0. In step 3, we assume the state of the encoder is 1. It is at state B. It is at initial state B. And we assume the incoming bit is 0. After applying the clock pulse, this 1 gets discarded. This 0 comes to M1. So this is nothing but state A. So M1 represents state of the encoder. So if the incoming bit is 0, the state changes from state B to A. B to A. So this is the initial state and this is the final state or next state. In step 4, again we assume the encoder is at state B, that is it is at state 1, and we assume the incoming bit is 1 and we apply the clock pulse. This one's go out, it will be discarded and this one comes to here. So state changes from 1 to 1, that means B to B. State changes from B to B. So try to understand to prepare this state table, because this state table is very useful to draw state diagram, code trails diagram, tree diagrams. These diagrams are graphical representation of convolutional codes, related graphical representations. So from these graphical representations we can find output of the convolutional encoder for any given input. So this will be the present state, and after applying the clock pulse we change it to these states. So initial state is like this, and next state will be, you blindly remember, next state will be always the first column. In case of L1, L1 means constraint length 1. For constraint length 2, first two columns will be there. We will see that in next example. So the initial state is this one, and both will be same. State A, AB, AB. So this is AB, AB.
After we prepare the state table, from that state table we can draw the tree diagram. So conventions we use to draw the tree or a code tree diagram is, if the incoming bit is 0, we go up. If incoming bit is 1, we go down. So we go up and down depending on the input to bit stream. So this is a root node. So this is the start node or a root node. If the incoming bit is 0, then we go upside. If the incoming bit is 1, we go downside. Then again we go to the next state. If the incoming bit is 0, we go up. We go down if the incoming bit is 1. Like this we expand the tree diagram of a given convolutional encoder. Here various nodes are represented. So the code tree starts from root node, and various other nodes are represented. Each node represents state of the encoder. State of the encoder changes depending on the incoming bit, whether it is a 0 or a 1. So these are the, so here we have to find, this is the state, next state. If this is the present state, this will be the next state. We have to find the state of the encoder and also output. So this branches, this branch, this branch, this branch. So we have to find output of this branch. So here we have to find two things. One is the output of the encoder and also the state of the encoder for the coming input bit. So state table is required to draw the code tree diagram of a convolutional encoder. So we have already seen how to obtain the state table of a given convolutional encoder. So this is the root node. We will start from the all 0 state or a root node. See, if the incoming bit is 0, so we are at this state A, and if the incoming bit is 0, we go up, and the state changes from A to A. So the next node will be A, and the output will be 0 0. So output is represented as a 0 0. This 0 represents incoming input message bit. Suppose if the incoming message bit is 1, if the incoming message bit is 1 and the encoder is at state A, the encoder is at state A, then state changes from A to B. So the next state will be B. The output will be 1 1, and on this branch we represent both input and output. This one represents the incoming message bit. Similarly, we will try to find the node here. The incoming bit is 1 and the encoder is at state A. Encoder is at state A, the incoming bit is 1, so it changes from A to B, that we have already represented. Coming to this state, we will try to find what is the state of this encoder or node. The incoming bit is 1. The incoming bit is 1 and the encoder is at state B. The incoming bit is 1 and the encoder is initial state B, and the state changes from B to B. So this will be B. This node will be B. So again, suppose we try to find the state of this encoder at this node. The incoming bit is 0. The incoming bit is 0 and initial state B. Initial state is B and the incoming bit is 0. The state changes from B to A. State changes from B to A. This will be the A and the output is 0 1. Output is 0 1. In this manner, we will fill all the next states of the encoder and output of the encoder for the coming message bit. I will explain two more states to make you understand better. Suppose if you want to find the state of this encoder at this node, incoming bit is 0 and the encoder is at state A, initial state is A and the incoming bit is 0. So it goes, the state goes from A to A. So this will be A and the output will be 0 0. And we will find the state of this encoder at this node. The incoming bit is 1 and the encoder is at initially state B. State B and the incoming bit is 1. So the state changes from B to B. So this will be B to B and the output will be 1 0. So by looking at the state table, we can fill all the branches of the code tree and we can expand to any number of branches. So make practice to fill all the nodes of the code tree and find the output values of the encoder for the given message bits. Now we have to find encoder output from the tree diagram. Suppose the given input sequence is 1 1 1 0 1. So we have to draw a path like this. Suppose this is the 1. So this is the incoming message bit. We draw 1 and the next incoming bit is 1. So again we have to go down. The next incoming bit is 1. Again we have to go down. And the next incoming bit is 0. So we have to go up. Next incoming bit is 1. We have to go down. So we can see the output. So the output 2 will be 1 1 for this and 1 0. Again 1 0. 0 1 1 1. 0 1 1 1. So this is the encoder output for the given message bit, message string. If you want PDF files of my video lectures, please visit www.engineerstutor.com. For PDF link, see description of the video. You can also write to me at rkgopal2020@gmail.com for any doubts and queries.